Hey, what's up, guys? It's your boy here, or Super J. Welcome to Calculus Lessons. Today we are learning about limits. So, what is a limit? A limit at a point is where the graph is supposed to go, but it doesn't. On this graph here, the limit is the white dot. So, there are two scenarios where the limit of a point exists. It could either be the graph on the right, where the point is the same as the function value when you plug in x. Or it could be the graph on the left, where the function is defined somewhere else on the graph, but the white dot shows that this is where it was supposed to go. In that case, the white dot will be the limit. So there's a special case where it comes to finding limits on a graph. The special case is where the graph starts on one side of a point and then continues on another side of the point. In that case, the limit at that point does not exist, but the limit before and after it does. So in math, when you see that little 2 minus, that means we're talking about before we get to that point. So in this case, it will be when x equals 2. And the 2 plus means after x equals 2. And don't forget that the limit as a point could be the same as the function value on the graph. Calculating limits. So when it comes to calculating limits, no matter what you do, the first step is always start by plugging x into the equation. Calculating limits as a fraction. When the equation they give you is a fraction, there are 4 scenarios that can happen. A number over a number. In that case, the limit is the quotient or that fraction itself. When you get 0 over 0, that means you have to do something else. Most of the time, you might have to factor out something. When you get a number that's over 0, that means that the limit does not exist. But when you get 0 over a number, that means that the limit does exist and it's 0 itself. So going back to the equation shown for the calculating limits for fractions, the first step is to plug in the limit for the fraction. And when we go through the whole equation, we get that the limit is 0 over 0, which means we have to do something else. So the next thing I did was I was going to try factoring. Then I figured out that you could factor out the numerator, which gives you x plus 3 times x plus 1. The last step is to act appropriately, which means that the first thing I have to do is cancel out the x plus 3, and then I will put the number back in. After doing all that the limit at x equals negative 3 is negative 2. Calculating limits in a piecewise function. So when you calculate limits in a piecewise function, you have to plug in the x that they give you for a limit into both equations. For there to be a limit, the numbers have to be the same exact number. In this case, when I plug in 0 into both of the equations, they do not equal the same number, which means the limit does not exist. If there were the same number, then that number would have been the limit. And that's it for this video. In the description below is my Instagram, the Twitter if you want to know what I want to upload, and that's pretty much it. I'm out. Peace!